All right, so this is just a review over what we did last semester with proportions. Kind of wanted to review over proportions with you again just because this entire unit is basically going to be using proportions. And you're also going to be using a proportion when you get into probability and when you get into our inferences unit. So you need to make sure that you're very confident and very comfortable with setting up a proportion and solving a proportion. Setting it up, that's the most important part. Solving it is the easy stuff, but getting it set up correctly, that's the part that's the most difficult for some. So all that matters is how you set up your second ratio with a proportion. The way you set up the first one doesn't matter, but it will determine how you have to set up the second one. So in here, where it says a class of 32 students, there were 8 absent. A school's got 720 students. We want to know how many would we expect to be absent. So here's the information that was given to us. Right? This is that given information. And we talked about it. When we set up a proportion, we set up the information that was given and set it equal to the information that we're trying to find. Right? The information that we want to know. So the information that we're given is that there are 32 students. Don't forget to label. Don't just put numbers, put labels. There are 32 students. There were 8 who were absent. 32 students, 8 of them were absent. So that's how I'm going to set up my first ratio. I could put 8 over 32 if I wanted to. That would be 8 absent over 32 students. That's perfectly fine. But it does determine how I have to set up my second ratio. Based off of how I set up my first one, where am I going to place 720 students? Is that going to go on top or bottom? Top, right? Because it's students. 720 students. Since students were originally on top for the first ratio, I have to place it on top for the second ratio. So 720 students is going to go on the top. We want to know how many would we expect to be absent. They don't give us a value, so what do we place when we don't have a value? An x, a variable. Okay, so we place an x. There's x amount of students that were absent. Okay, so there's our ratio, the information that was given and the information that we're trying to solve for. Now from here, we just do our cross product. Remember, we multiply the diagonals, starting with the variable. Okay, so the variable is diagonal to the 32 students. So we're going to do 32 times x. 32 times x comes out to 32x. Okay, then we're going to multiply the other diagonal, the 8 times 720. 8 times 720 is going to come out to 5,760. So we now have the equation 32x is equal to 5,760. From there, we just divide. We're going to divide both sides by 32. And we get that x is going to be equal to 180, but 180 represents the number of what? Absent students, right? X represents the absent students. So it's 180 absent. You always want to attach a label with it. Don't ever just put a number. What does the number represent? Okay, Chisimdi, I'm going to ask for you to take off your hood, please. Thank you. All right, for problem number 2, Josh paid $3.72 for 3 pounds of apples. How much is 7 pounds of apples going to cost John? So again, we take that first piece of information that's given to us. This is the information that's been given. $3.72, 3 pounds of apples. So I'm going to set this up as 3.72 on the top for dollars. And I'm going to put 3 pounds on the bottom for the apples. So there's my first ratio. Now I need to set it equal to the information I want to find out about. I want to know how much is 7 pounds of apples going to cost. So where is 7 pounds going to go? Top or bottom? Bottom, right? 7 pounds. Pounds goes on the bottom here. So we're going to put 7 pounds on the bottom. That means it's X dollars is going to go on the top. We don't know how much money, so we just put the variable. Okay, once it's set up, you just do your cross product to solve. Start with the variable. We're going to multiply x times what? X times the 3 pounds. Remember, do the diagonal. Guys, I know that it's been like a couple of weeks, but you need to wake up, okay? We've got X that we're multiplying by the diagonal, which is a 3. So we're doing 3 times X. That comes out to 3X. What are we going to multiply next?
$3.72.
Thank you, Alan. No more answering questions for you, okay? All right. 3.72, we're going to multiply that by 7. $3.72 times 7 is going to come out to 26.04. Eli, what are we going to do next? We just finished here. What are we going to do next? We have 3x is equal to 26.04. What do we do to solve? Come on. Hands down. He can get this. He's a smart kid. How would you solve this one-step equation, Eli? What is the inverse operation that we need to perform? Thank you. What are we going to divide both sides by? 3. Okay, make sure you're paying attention. We're going to divide both sides by the 3. X is going to come out to $8.68. I put the dollars because that's what X is representing. X is representing the money. All right, Kaylee can read 93 pages in 62 minutes. How long will it take her to read 171? So here's the information that's been given to us. 93 pages, 62 minutes. So I'm going to put 93 pages on top. I'm going to put 62 minutes on the bottom. So 93 pages over 62 minutes. 171 pages. 171 pages. Brooklyn, where am I going to put 171 pages? Am I going to put it on top or on the bottom? On the top. Very good. 171 pages is going to go onto the top. On the bottom, it's just your variable. We need to know how long it's going to take her to read that, so that's X minutes. Let's start with multiplication. We're going to start with our variable X. What are we going to multiply with the X, Nathan? If I start with the X, what am I going to multiply it with? 93. So we're going to do 93 times X, which comes out to 93X. Okay, then we're going to multiply the next set of diagonals, which is the 62 and the 171. So we're going to multiply 62 times 171. When I do 62 times 171, what do I get for that, Caleb? 10,602. 10,602. You get 10,602. What's the last step that we need to do here, Chisimdi? Divide both sides by 93. And what do we get, sweetie? 114. Okay, so we're going to get X is equal to 114, and that represents what? 114. What does X stand for? Minutes. So we had to put 114 minutes. Okay, that's just a review. Again, we need to know how to work out our proportions because today we're going to be focusing on what's called a percent proportion. The value of is over of equals a percent over 100. Is, another term for the is, represents a part. Is a representation of the part. Of, the value of is going to represent the whole. So when you're given a word problem, your word problems tend to be split up into parts and wholes. And then, of course, you've got a percentage, and a percentage is always out of 100. So this 100 is never going to change. That 100 is always going to be there. That is the only thing that is ever going to be constant about your percent proportion, that 100. Okay, your percentage always goes over it because a percent is out of 100, and then you have your part over your whole. Then you're going to set it up as a proportion and solve for the missing portion. Okay? So for here, we have some blanket statements. These are just some simple, straightforward statements. no determinations of parts and wholes. You are determining it based off of the words is and of. So what we want to do is we want to break these problems down by identifying what value represents the is, what value up there is going to represent an of, and what value is going to represent the percent. The percent is the easiest one to identify because it's going to have a percent sign attached to it. It'll have a percent sign attached to it. Okay, so let's look through here. We've got 50 is 20% of what number? 50 is 20% of what number? Let's start with the first number we see, 50. Do you think 50 is going to represent the is, of, or percent? Well, first thing you should ask, does it have a percent sign attached to it?
No.
No, so is it going to be a percentage? No. What's the only key word you see around it? Is. So what do you think that is? It's an is value. 50 is. 50 is, that makes it an is value. So for the is, we're going to replace it with 50. Then we've got 20%. Is that an of or a percentage? A percent. A lot of people get confused. They're like, oh, but it says 20% of, but it says 20%. It says 20%, that means that it is a percentage. Okay, so here's our percentage. That's going to be the 20. Of what number? We don't know. We don't know what the number is going to be, so what do we put when we don't know a number? X, a variable. So we've now identified those three key components of the proportion. Remember, the fourth component is always going to be that 100. That 100 is never going to change. So then we're just going to set it up. We're going to set it up as is over of. So that means it's going to be 50 over X equals my percent over 100. My percent was 20. 20 over 100. And then we just solve. We do our typical cross product. We multiply our variable with its diagonal. So that would give us 20x. We multiply the other diagonal set, which was 50 times 100. That gives us 5,000. And then what's always the last step to do? Divide. And what are we going to divide both sides by, guys? 20. We're going to divide both sides by 20, and we're going to get that our of value in this case is 250. Let's do one more together. Number 2, what percent of 20 is 4? What percent of 20 is 4? So we want to identify our is, our of, and our percent. We're going to identify the is, the of, and the percent. So let's take it in one number at a time. The first number I see here is a 20. Is that an is, an of, or a percent? Of, right? It says of 20. Of 20. That's an of value. What about the 4? Is. It says is 4. Okay, of 20 is 4. So the 4 is going to be our is value, which means that the thing that's missing is our percentage. Makes sense? It says what percent. Well, we don't know what the percent is going to be, so that's our variable. We're going to put an X. Now we just fill in the information. 4 over 20 equals X over 100. Is over of equals percent over 100. And now we just do our cross product. Multiply your variable first, so we do 20 times the X. That gives us 20x. Multiply your other diagonal set. So we're going to do 4 times 100. That gives us 400. And then the last step is to go ahead and divide. We'll divide both sides by 20. And we'll get x is equal to 20. And since this is a percentage that we're looking for, I've got to put my percent sign behind it. Okay? Go ahead and finish copying that down and then turn your paper over. You're going to do problems 3 and 4 on your own. All right, so for question number 3, we've got 60 is 25% of what number? 60 is 25% of what number? So the value 60 represents our what? Our is. The 60 represents our is. Okay, what about the 25? What does that represent? The percent, right? It represents the percentage because it says 25%. So that means the of is the value that is missing. We do not know the value of our of, so we put our variable there. So when we set this up, we're going to set it up as 60 over x is equal to 25 over 100. That 100 is always the same. We're going to do our cross product starting with our variable. We'll do 25 times x, which gives us 25x. Then we're going to multiply 60 times 100. That gives us 6,000. And then our last step is to go ahead and divide both sides by 25. And we find out that our of value is going to be 240. Okay, for problem number 4, it says what number is 32% of 1,000? What number is 32% of 1,000? So 32, is that an is, an of, or a percent? It's a percent, right? It says 32%, that makes it a percentage. What about the 1,000? What is that? Of. Okay, it says of 1,000, of 1,000. That makes it an of value. What number is? That's the value that is missing. We don't know what that value is, so we're going to put an x for our variable. Okay, so that gives us x over 1,000 is equal to 32 over 100. X over 1,000 equals 32 over 100. We first start by multiplying with our variable, so we're going to do 100 times x, that gives us 100x. Then we're going to multiply 1,000 times the 32, that gives us 32,000. Our last step is to solve for the is value, which means we're going to divide both sides by that 100. And we'll get that our is value is 320. Really simple and easy, just mapping it. You have to map it with the correct phrasing. Now, like I said before, not every one of your values, though, is going to be a simple statement. Sometimes it's going to be a part, which is your is, or a whole, which is your of. So you have to read through these word problems and figure out, okay, the information that's being given to me, is this part of the problem or is this the whole of the problem? Okay, so you have to sometimes use a little bit of logical thinking. Okay, so for example, problem number 5, the number of 7th graders in the school is 312. This is 39% of the student population. So how many students are in the school? So looking back, 312 represents the 7th grade. Is that part of the school or the entire school? Part, right? 7th grade is only a portion of your school, isn't it? You got 6th grade, you've got 8th grade. So 7th grade students is only a part. That means that 312, that's a part of your problem. So let's go ahead and put a box around this. This information right here is going to represent the part. So remember, part is the same thing as is. That's our 312. Now 39's a percentage. 39 is a percentage, so we're going to go ahead and put the percent is equal to 39. That means the of value, which is how many students are in the school, that's your whole. That's the information that's missing. We don't know this piece of information, so we're going to put our variable x. So we've got our part. We don't know the whole, but we do know the percentage. And now we set it up just like you set up your is over of equals percent over 100. Instead of is over of, it's part over whole. So you have 312 over x equals 39 over 100. And then we cross product to solve. Multiply your variable first, so x times 39 gives us 39x. Then we're going to multiply 312 times 100. That's going to give us 31,200. And then we'll divide both sides by 39. Only difference here is you just can't put a number. You have to relate it back to what it represents. So when we divide, we're going to get 800. but that represents 800 students, or total students, 800 total students. Can't just put 800, but you have to put down what the total amount would be, or what it represents. Okay, go ahead and try number 6, 7, and 8. Identify your part, identify your whole, identify your percent, and then set up your proportion to solve. All right, let's take a look here. For problem number 6, Sally's soccer team won 17 games. They played 25 games. What percent did they win? So 17, is that a part, a whole, or a percentage, Josefa? Part, right? Part of their games they won, right? They didn't win every single game, but they did win some of their games. 17 of the games is what they won. So that's considered to be the part. Okay, so part is going to be 17. 25, is that a of or a percent? Or like a whole or a percent? Whole, right? They played 25 games. That's all the games that they did. So that's the whole. The percentage is what's missing, right? It says what percent, so that means we don't know it, so that's our missing value. So we set this up as 17 over 25. It's going to be equal to x over 100, and then we do our cross product. Multiply the variable first, 25 times the x, that's going to give us 25x. 17 times 100 gives us 1700, or 1700. And then we just divide by 25. Okay, when we do 1700 divided by 25, we're going to get what? What's 1700 divided by 25, guys? 60, what? 68. 68 should be 68%. So 68% of the games that they played, they won. Okay, problem number 7. 15% of students at Northbrook Middle School are absent today. There are 920 students in the school, so how many of them are absent? So 15, is that a part, a whole, or a percent? Percentage. Right, it says 15%. That's a percentage. 920, is that a part or a whole? The whole, right? 920 students in the school. The school is the whole, right? So there are 920 students in the school. That's the whole. Some of them are absent. Not everybody's absent. Just a part of the school is absent. And we don't know how many, so we're going to put x. Okay, so x over 920 is equal to 15 over 100. Cross product, we're going to multiply the variable first. We're going to do 100 times the x, which gives us 100x. And then we're going to do 920 times the 15, which gives us 13,800. Okay, last step is to divide both sides by 100. And we get x is equal to 138, and that 138 represents the amount of students that are absent. Represents the amount of students that are absent. Now the last one's a little bit tricky. It says there's 20 questions on a test. 25% of the answers are choice B. But we want to know how many questions on the test are not choice B. We want it to not be choice B. So if 25% is choice B, what percentage is not choice B? 75, right? A percent is out of 100. 25% of it is B. That means the rest of it, 75%, is not going to be B. Okay, so the percentage that we're going to use is 75%. 75% is not B. So we're going to put percentage is 75. So now the only other number we have to focus on is the 20. Is that a part or a whole? 20 questions on a test. Is that part or a whole? Whole. Right? Questions on the test, that's all of the test. That's the whole. So we want to know what portion of the test is not going to be answer choice B. Okay, so we set it up as x over 20 equals 75 over 100. And then we can multiply. Do your cross product. We're going to do 100 times the x, which is 100x. We're going to do 20 times the 75. That's going to come out to 1,500. And then the last step is to divide both sides by 100. And we get 15 questions. 15 questions that are not answer choice B. Okay? What you're going to be doing today, you're going to get onto your Google Classroom. You're going to log into Google Classroom and you have IXL. You've got IXL. You need to make sure you log into the IXL and are actively working. My two new students, my two new Kennedys, come on up so that way I can get you logged into Google Classroom for us.
How is it 75%?
Because 100 minus 25 is 75. Right, 25% is B. It'd be like me saying, okay, 25% of the class is boys. So what percent is not boys? 75%, right? Get your computer. Do you have your computer? Did they give you a computer today? They didn't give you a computer? Okay, grab one of the computers up over there. You don't need headphones. Noman's going to go first, and then you may go after. Come on around here, honey. I'll put my mask on. All right. Oh, as soon as you're logged in, let me know, and then I'll get you into my Google Classroom, okay? And do you remember your IXL login? No? Did you guys use it often in Mr. Alfred's class?
Yeah, but he had like this slip on Google Classroom that we could check.
Okay. Kennedy, the other one, sorry. Kennedy F. Did you get logged into the computer yet? Can I get the computer so that way I can get you logged into Google Classroom? Thank you. Still need you to log in this part. I need you to log in this part. Same login as what you got into the computer with. So every day when you come into class, you'll want to make sure you get logged into here, and they'll get you a computer soon. And then you'll always go to Google Workspace for Education. When you get into there, that's your Google account through Gwinnett County. Okay? Everything we do in class gets connected to Google Classroom. So I'm going to put you into our Google Classroom right now. All the notes, so everything I did right here the entire time, it's recording. Okay? Stop.